Okay, so for 2.2, I just want to talk about that one quickly. As it is clear to everyone, not only the x has a fraction as an exponent. What is the exponent of 6 here? Isn't it 1? Right? If it's just a 6 with no exponent written, then the exponent of 6 is actually 1. So when you write this whole thing in surd form, the 6 can't go in the root. So the 6 isn't raised to the power of that fraction. Only the x. So the 6 has to stay in front, and the x is what you change. Okay, so remember the numerator becomes the exponent on the inside, and that should be x to the 1, and the denominator becomes the number on the outside of the circle. Okay, but the 6 has to stay on the outside. This one is different. Now here, because this whole thing is in brackets, that means that the 3 and the x squared must go into the circle. Right? Because the whole thing, the 3 and the x squared, both of those are raised to that fraction exponent. So what I did was, I just took this whole thing, right? 3x squared. The numerator becomes the exponent on the inside of the surd, and the denominator goes on the outside. Okay, so that's what I did. So the whole thing is now raised to the power of 2. And then if you wanted to just simplify it there, so all I did was I just say 3 squared and x squared. But for the purposes of this exercise, we didn't have to. Okay, this one was just practicing going from 1 to 1. So guys, it's very important that you're understanding the difference between these two. Okay, in 2.2, the 6 is not raised to the power of that fractional exponent, so it stays in front. In number 3, the whole thing is raised because of those brackets. Okay, so the whole thing goes into this one. Any questions? All right, for exercise 7, 1.10, I didn't finish because I just wanted to show you guys some multiple options. And the easiest way of actually simplifying that one, I wanted to show you guys. But 1.2, you can mark. I got an answer of 16. Right, so I suppose there were different things that you could have done here. What I did was I just first wrote it in exponential form, right? So 64, the exponent on the inside becomes the numerator, the number on the outside becomes the denominator. Right, and we find that's it. That will get you a mark. Okay, then remember what we practiced yesterday. If you have a fraction as an exponent, you can often write the base with an exponent that will cancel out the denominator of the fraction. So the denominator here is 3. Right, so I ask myself, can I write 64 as something to the power of 3? Right, because then it will cancel out that 3 at the bottom. Okay, so that is what I did then. I rewrote 64 as 4 to the power of 3. Okay. Which is different from what we've done in the past. In the past, we've done prime base. Okay, now we're not actually looking for prime bases. Now we're looking for an exponent that will cancel out that denominator. Right, those two numbers are supposed to be. So then this step, you don't have to show the step where you're multiplying them. All right, you see in the next one, I didn't actually show that step, but we know that that is what will happen, right? So the next one is inside the bracket and outside, so you're going to find them together. That is going to cancel out. You measure 4 to the power of 2 only, which is 6. Okay. So let me just see. You would get a mark for that. You would get a mark for writing 64 as 4 cubed. And then you'll get a mark for kind of here, but this is almost like together with the answer. Right? Showing that that 3, those 3. But guys, if you just take this and you're just like, oh, I'm just going to type it into the calculator and you write the answer. Okay, but not without using a calculator. So it is important that you can do this. Okay, any questions on 1.2? Okay, so the last one here, this one was quite complicated because we had 3 bases that had fractions as exponents. But in each case, I just tried to write a base with an exponent that will cancel out the denominator, right? So you can see I've circled the denominator. So 81, I need to write as something to the power of 4, right? And 81 is actually 3 to the power of 4. Okay? The reason we're doing that is so that the 4, the diamonds times the 2 together, right? The 4s will cancel out. Okay, so that's what we do in each case. Here, 27, I need to write as something to the power of 3. So 27, we all know is 3 to the power of 3, so the 3 will cancel out. Okay, for 9, that denominator is 2, so I need to write 9 with an exponent of 2. Okay, so the 2's will cancel out. Then you can see what I'm left with in each. 3 to the negative 3, 3 squared, and 3 to the power of 3. All right, from here you could actually work with the numbers, right? Because they're no variables, it's all numbers. You agree with that? Right? 3 to the negative 3 is a number, 3 squared is a number, and 3 is a number. So what is 3 to the negative 3? There's a negative exponent. What do I do with it? I have to move it, right? So that's actually going to be 1 over 27. Which 1 over 3 to the positive 6, right? Which is 27. 1 over 27. And in brackets, what's 3 squared? 9 minus, what's 3 cubed? 27. Right, so you could actually just work with these numbers. Yes, you could, yeah, definitely. So the question there is, could we put the whole bracket over 27? Yes, we can. Now guys, from here, again, you can, sorry, decide what you want to do here. You can either multiply the 1 over 27, or you can work this out and then multiply it afterwards. What do you guys want to do? Multiply in first or subtract first? Subtract first, okay, that's fine. 1 over 27. What is 9 minus 22? Minus 18. Okay, and now we need to multiply those together, right? The quickest way of doing this, because remember you're now technically not supposed to use your calculator, right? I would do that. So do we agree that negative 18 is just over 1? Right, so you see what I'm doing there? I'm just saying 1 times negative 18 is negative 18, and so 7 times 1 is 27. Okay, but now we just need to check if that's the simplest form of that fraction. What number can go into both of those numbers, 18 and 27? 9 goes to both of them, yes. So now, divide by 9, divide by 9. What's my final answer here? Negative 2 over 3. Guys, I know you can just do all of this on the calculator, but I'm going to say again, the instruction says that you're not allowed to use a calculator. You have to show all of these things. Okay, you have to prove to me, the person that's marking your case, that you don't use a calculator at all. But technically, I mean, you could use it, right? As long as you are writing down all your steps. Okay. Another thing is, obviously, you can just type this whole question into the calculator and see if it gets to that answer at the end as a way of checking your answer. Right? You are taking an answer. Okay, now we are going to apply all of this to equations. So that is the next heading, equations with rational exponents. I'm just going to zoom in a bit there. Okay, now guys, do you remember when we did, oh, sorry. Right, guys, you remember when we did third equations, right? When we had like the square root of x is equal to a number, we raised both sides to the power of 2. We square both sides to cancel out that square root. Right? You remember that? We're going to do a similar thing here. We are actually again going to raise both sides to the same power, but we need to choose that exponent so that it will cancel out the one that we have. Okay, so I'm going to write on the side here. Raise both sides So guys, when I say will cancel out, I mean that we're looking at this, for example, 3/2, right? If I times 3/2 by 2/3, what's going to happen then? You have a 3 at the top and then a 3 at the bottom. What's going to happen with those 3? They're going to cancel out. And then I have a 2 at the bottom here and a 2 at the top there. They are also going to cancel out, right? What's going to be left? 1. So that is what we're going to try and do, guys. We're basically going to look for an exponent that when I multiply it by this exponent, I don't know why this keeps screaming. We're going to look for an exponent that when I multiply it by the fractional exponent that I have, it will cancel it off. It will give me 1. All right? So in this case, we're going to raise both sides 6/3, which is just this fraction swapped around. Okay? So we're going to say I have this x to the power of 3/2. I'm going to raise that to the power of 2/3. You take the same fraction but you swap the numerator and the denominator. Okay, but then just like we did when we did squaring both sides, this is an equation. Whatever we do on the one side, we have to do on the other side. So on this side, I must now also say 27 is raised to the power of 2/3. Guys, remember when you have an exponent inside a bracket and outside a bracket, what you do with those exponents, you times it, right? So this is going to become x to the power of 3/2 times 2/3. Again, that's a step that you don't actually have to write down, okay? But just because it's possible, we're doing that. And now this is what's going to happen, right? What we wrote down on the side. The 3's are going to cancel each other out, and the 2's are going to cancel each other out. So in the next line, I'm actually going to be left with x to the power of 1. Okay, which is just x equals something. That's what so guys, for this 27 part 2/3, we now need to use what we practiced yesterday in order to simplify that without using a calculator. The denominator is 3. So can I write 27 with an exponent of 3? What is it? 3 cubed, okay? To the power of 2/3. Again, like what we practiced yesterday, why am I doing that? So that this 3 will now cancel out the 3 in the denominator. Okay, over here I am now left with x to the power of 1. You don't have to write that 1 there. But you can if you want, just to show that we've now multiplied those together and we're getting 1. And what's left on this side? 3 to the power of 2. 3 squared. So what does that mean? X is equal to 9. Yes.
Would this question be without the
If they don't say anything about not being able to use a calculator, then you can type this into the calculator there. But let's rather just practice doing it without, okay, just to be safe. But they could say, you're not allowed to. Okay, guys. So here, raise both sides to an exponent that will cancel out the fraction. Right? So this is going to be therefore, so what? Fraction around. And that's what we're going to do every time. And we're going to practice a couple of more these. So if the original fraction was 3 over 2, we raise it to the power of 2 over 3. Right, this one. So the next one. X to the power of 5 over 3. So guys, you need to recognize, okay, my exponent is now a fraction. And if that happens, then you're going to use the method. All right? So what am I going to get if I swap 5 over 3 around? 3 over 5. So I'm going to raise both sides to 3 over 5. So I'm going to say x to the 5 over 3 to the power of 3 over 5. Right? So I'm just swapping that fraction around. Is equal to 32 to the power of 3 over 5. Now you remember when you have an exponent inside and outside the bracket, you try and think together. So the 5s are going to cancel off, right? And the 3s are going to cancel off. But if you're showing those little lines, please make sure that I can still read what you wrote here. Okay, because you'll get a mark for that exponent. So I have to mark this part. You need to be able to make out that that's 3 over 5. Okay, so this is going to give me x to the 1. What am I going to do on the other side? The denominator that I have is 5. So I need to write 32 as something to the power of 5. 2 to the power of 5. Thank you. So here, this is going to become x to the 1, which is just x. You can write that 1 x. Right? And on the other side, I'm going to write 32 as 2 to the power of 5. And that is still to the power of 3 over 5. And now you can show that the 5 here is going to cancel out the 5 in the denominator. So what is x, right? What's left? 2 to the power of 3, which is 8. Then add in another step, x equals 2 to the 3, and then 8, that's fine. Okay, but that's what you're going to do every time, guys. Right? Okay, let's look at that one. 8x to the power of 3 over 4 minus 27. this one is different from the ones that we've done so far, right? The previous two was just an x and an exponent equal to a number. Now we do need to get it in that form each time, right? So before you can raise both sides to a power, remember what we did with the surds? Remember we isolated the surd first and then we square both sides. All right, so we need to do the same thing here. We need to get this on its own before we raise both sides to the same power. All right, so first we're going to isolate the x. So isolate the variable before raising both sides to an exponent. But now we get x. Yeah, we're gonna do that with x. Okay, so that now. When you are getting a question like this in a test or exam, they're gonna give you a bunch of different equations mixed together, right? So it's not gonna be like with the heading, equations with rational exponents, solve these. You need to be able to look at this equation and identify that you have an x to the power of a fraction, right? Meaning you must first get the x on its own and then raise both sides to a power. So that we are actually going to have to like memorize the different types of equations that they are and what to do in each case. Okay. But I can maybe make a summary for you or something. All right, so we're going to move this minus 27 over first. It's going to become positive 27, right? We're going to have 8x to the 3 over 4 equal to 0 plus 27, so just 27. And now we're going to have to divide by 8. All right, so we're going to have x to the power of 3 over 4 is equal to 27 over 8. Now, 8 unfortunately does not go into 27, all right? But we're going to leave it like that for now. I don't want you to panic. Okay. Now we have our x isolated. Now we can raise both sides to the same exponent. So we look at the fraction with 3 over 4. What do I get when I swap that? 4 over 3. I'm going to raise both sides to 4 over 3. So I'm going to say x to the 3 over 4 to the power of 4 over 3 is equal to the other side, the whole fractional, to the power of 4 over 3. Guys, even if that's the only thing I can remember, you get a mark for doing that. Okay, you get a mark for raising both sides to that fraction of the swap around. So please do that. If you don't know how to go further, you can at least take credit for doing that. Right, so now the 3's cancel out. The 4 at the bottom and the 4 at the top will cancel out. So I'm left with x on this side, x to the 1. Now this one, guys, what is the denominator of this fraction that I have? The denominator is 3. Yes. So if I wanted to do that, I would have to make my exponent moving. Alright, so if you want to swap this fraction, then the exponent needs to. Alright, so guys, here the denominator is 3. So we need to write the base as something to the power of 3. Right? What's 27? 27 is 3 to the 3. And what about 8? 2 to the 3. So that's what we're going to do, guys. We're going to write 27 as 3 to the 3 and 8 as 2 to the 3. And that is all to the power of 4 over 3. What happens when you have a fraction? I'm just going to rewrite this rule that we looked at yesterday as well. When you have a fraction raised to an exponent, the whole thing You raise the top to that exponent and the bottom, right? You remember? So now I'm going to have to say 3 times 4 over 3 at the top and 3 times 4 over 3 at the bottom. In both cases, the 3's are going to cancel out. Okay, so you write both of them with an exponent. Those will cancel out the denominator. Okay. So what's left now, guys? 3 over 2 to the power of 4. Can I simplify that? What do I do with the 3 and with the 2? Let's both be raised to the power, right? What's 3 to the power of 4? 81. Got that one wrong yesterday. It's 81. And 2 to the power of 4 is 16. Right, so that is the answer. Exactly. Yeah, if they want to do the after you calculate, they have to be. Okay. Now guys, what I want you to notice is that in all 3 of these examples that we've done now, right, this is looking at the fractions, the numerator was always an odd number. Right, so you see that the numerator in the first one was 3, in the second one was 5, and then the third one was also 3. When the numerator is an even number, we need to do something different. I'm going to show you now. It's the same method, we just actually need to add something extra, right? So I'm just going to write here, numerator of fraction is even. So guys, you might remember an equation like this from previous years. I know that this is different. This is not technically a fraction, that exponent, but I just need to explain to you why we must do something external. Okay, so we'll do another one now. But what if that exponent there is 2? Can I write that as 2 to the 1? Okay, 2 is the same as 2 to the 1, right? So I can rewrite this as x to the power of 2 over 1 is equal to 9. You wouldn't do that. Okay, I'm just showing, I want to show you guys. Okay. Now you would say, what's the opposite of 2 over 1? 1 over 2, so you would raise both sides to the power of 1 over 2, but you have to put a plus minus in front. I'm going to show you why just now. Right, you have to put a plus minus. Guys, what does that mean in math? There's a plus minus in front of a number. Means that there are 2 options, right? Remember when we did the quadratic formula, we did a plus minus, meaning you get 1 answer when you do a plus, and you get 1 answer when you do a minus. Okay, so I'll show you now why we're doing this. We should get the answer here. Now the 2 at the top is going to cancel out the 2 at the bottom, and the 1 will also cancel out. All right, so I'm going to be left with x to the power of 1, you can decide x is plus or minus. So guys, what is the denominator there? It's a 2, right? Can I write 9 as something to the power of 2? 3 to the power of 2, okay? Take note, I wrote my plus minus again. Now the 2's are going to cancel out. So what's next then? 3 to the power of 1. So this is saying that x is equal to plus or minus 3. And guys, isn't that true? Because what is this equation saying? This equation is saying whatever your x value is, when you square it, you get positive 9. What's 3 squared? 9. What's negative 3 squared? Also 9. Right? So because you're squaring it, you actually are going to have 2 answers for x. Okay? But you need to remember that, guys. How would we have solved this before? before. You didn't know the things because I've just shown you the second now. Yes. Yes, exactly. Yeah, correct. So it won't work if this was like a 2/5 or something. Okay. So the numerator is even, yeah, but it might not always work. So I'll show you now what to do when all right, so in the past, you would have done this, right? You would have taken that 9 over, and you would have said, this is actually quadratic equation, all right? Okay, x squared. So you technically would have to take that 9 over and make it here, and then you would have to do your difference of 2 squares. Okay, so you would say x plus 3, x minus 3 equal to 0, or you can use the quadratic equation for that if you want to do quadratic formula, right? Your A, B, C. From here, you would say the first bracket is equal to 0, or the second bracket is equal to 0. There you would take that x is -3 or x is positive. Right? Two answers, 3 or -3. And my intention is not to confuse you now, all right? You can keep doing that, absolutely. All right? If it's just a quadratic equation, you can solve it like you would always solve a quadratic equation. But you can actually now also apply this method. All right? If it's an x plus 2 and this is the number, you can do your whole raising both sides to the same power. But what you have to remember is that if it's an x squared, you're supposed to get two answers, a positive and a negative answer. All right, so when the numerator of the fraction is even, you are going to have to, sorry, that's a very funny way of writing it. You're going to have to put a plus minus in front of your answer. We're going to practice some more now. And that is something that you must remember. In order to get two answers, you have to introduce the plus minus. Okay, it's not there by itself. You need to, when you're raising both sides to that same power, if you see that the numerator of the fraction, that exponent, is different, you have to remember that as soon as you raise both sides to the same power, you just put your plus minus. Okay, so that's something that you must remember, guys. So just circle that 2 and circle this plus minus. As soon as you see that that numerator is even, you have to remember to put a plus minus. Yes.
Only when it's after the.
No, so even when it's over something else as well, so if it was like a 2/5, you would also have to put a plus minus. Okay, so you're looking just at the numerator. It doesn't matter what the denominator. Okay, we're going to do another one now, which is a different one. Okay, guys, I'm just going to go back up to the previous ones. Say, for example, the numerator was odd, so we didn't have to do a plus minus. Okay, frustrating. In this one, the numerator was an odd number, so we didn't do a plus minus. In the first one, the numerator was an odd number, so we didn't do a plus minus. But when the numerator is even, you have to remember to put a plus minus. Okay, let's do another one. Example 5. X to the power of -2/3 is equal to 9. So now there's a lot of stuff going on here, right? So this is an test for exam. You have to look at this and say, okay, my exponent is a fraction. So I must raise both sides to the same power. But also, now it's a negative fraction. So that's for something else. And also the numerator is even. All right, so let's circle that. Make a little note. Numerator even, then plus minus. Is the variable isolated? Is it on its own? Yes. Okay, so we can raise both sides to the same power now. Now, guys, what must I raise negative 2 over 3 to get positive 1? Negative 3 over 2. Remember, we swapped the fraction around, but now because it's negative, our after exponent also has to be negative. Okay, so that's an extra thing there. Negative 3 over 2, and this is going to be 9 to the power of negative 3 over 2. So that's the only thing that changes when your exponent is negative, the outer exponent is also. Oh, and I already forgot something. The plus minus, just squeeze it in. Sorry. Highlight it so that we don't forget it again. Let's add to this note. Plus minus when you raise both sides. Yeah, how easy it is to forget that. Okay, we must remember that. Please, sorry about that, guys. So as soon as you raise both sides to that power, then the plus minus needs to be. Okay, you can't only add it at the end. That's where it's from that group. Okay, now we're going to say that the minuses are going to cancel out, right? The negative times the negative is the positive. The 2's are going to cancel out, and the 3's are going to cancel out. So I'm going to be left with x to the 1, x to the positive 1. You don't have to put that 1 there, you can if you want. Plus, minus. Now I need to work this out, right? The denominator is 2, so can I write 9 as something to the power of 2? 3 squared, so I'm going to say 3 to the power of 2, and that is to the power of negative 2. Now those 2's are going to cancel out. And what am I left with now, right? Plus minus 3 to the negative 3. Right, so x is plus or minus 3 to the negative 3. We're going to have to write that as a super thing. So what is that? 1 over 27, right? To get that exponent positive, so you're going to have 1 over 3 cubed, which is 1 over 2. Okay, but guys, I want to put your mind that you need to get that plus minus, you only use 1 more. Right, but let's try and remember that so that we can maximize the mark if we get on these types of things. Okay. So guys, I'm going to give you some of these to practice. Exercise 8 on page 12. Try to do 1 to 6. I'll write them down for you. Right, those are the questions, guys. Just ask me if you can't make up any of those exponents. And these things will be in your test, please, guys. So you have to practice them. I'm saying we're just doing one last section and then we're done with all the work for the week. Okay. Then we're gonna carry on with third, but the rest of third won't be done. Okay, get going. You can listen to music if you want.